For GCSE maths, you have to be able to simplify algebraic fractions. There are two very different types of simplifications that you need to be able to do. One of them would look like this, where there'll be one fraction that you need to simplify, and the other one, you might have more than one fraction and you'd be adding them or subtracting them, and it would ask you to simplify that as well. Sometimes students find it difficult to know the difference between the two, and they muddle up the methods for them, which ends up with the wrong answer. Now I will show how to simplify each of these two expressions. To simplify this first one, we will need to rewrite the numerator and denominator in factorized form and then work from there. So the top would become x times x take away 3, and the denominator becomes x take away 3 times x plus 1. Now I can see that there's a common factor of the numerator and denominator, and these will simplify. Now, what we've actually done here is we've written the numerator as a multiplication. It's a multiplication of x times whatever is in this bracket, which is x take away 3. And the same at the bottom, I've got x take away 3 times x plus 1. When fractions are written in this in this form, where you're multiplying something here and you're multiplying something here, you can cancel down. So we can cancel down the x take away 3, and then our result is x over x plus 1. Now these ones are a little harder to simplify actually. You have to add these two fractions, which means you need a common denominator, and that means they change quite a lot. So let's see how that works. Now if I multiply the first fraction, if I multiply the numerator and denominator of the first fraction by x plus 2, I get this. I get 2x times x plus 2, and in the denominator I will get x plus 1 multiplied by x plus 2. Now I'm going to multiply this fraction here by x plus 1 at the numerator and x plus 1 at the denominator. So I'm going to get 5 times x plus 1 over x plus 1 times x plus 2. Now the denominators are the same, so I can combine them and make them one fraction, and here I need to add this expression here to this expression. So let's see what that looks like. I'm actually going to multiply this out as well. So now I'm going to have 2x squared plus 4x plus 5x and plus 5. In the denominator I still have x plus 1 times x plus 2. Now I can still simplify the numerator, so I'm going to do that. So 2x squared plus 9x plus 5, and the denominator I can leave it in factorized form, or I can multiply it out, doesn't really matter. X plus 1 and x plus 2. Sometimes we need to check if this can be factorized, and then if anything cancels down. In this case it won't. I think it's important to notice how simplifying fractions like these is similar to these above here. Now I'll show you how they are similar. Now 6 over 9 can also be written as 3 times 2 over 3 times 3. Now notice how I've now written this as a multiplication. I'm going to do it to these as well. So in the second fraction I've actually got my multiplication already, so I've got 4 times x, and in the denominator I have 3 times 4 times x. Now again, you can see that now this has been written as a multiplication, and I've got common factors that will simplify. I'm going to do the same here. So factorizing this would mean writing it as a multiplication. So it would be x times x take away 3 over x take away 3 times x plus 1. So now I've got all of these fractions written as multiplications here, and I can see that some factors from the numerator are the same as the factors in the denominator, and these will cancel down. So we're going to do that now. So this 3 can cancel with that 3. The 4 can cancel with this 4. this x will cancel with that x. Here we've got the x take away 3 cancelling with this x take away 3 here. And then our results are, this is going to be 2 over 3. This is going to be x over 3. And this is going to be x over x plus 1. So what we've done here is that we've written all of these fractions as multiplications or products of factors. They're not always prime factors. And what we did was we simplified common factors that we have in the numerator and the denominator. Now I wanted to show how simplifying expressions like this are similar to adding or subtracting fractions like this. So the first thing that we did was we found a common denominator and we rewrite each of these fractions with that common denominator, and then we think about adding or subtracting. So for the top calculation, what we have is 3/5 take away 1/4. Now the common denominator is 20, so we can have 20, and then this would make the numerator 12. Take away 20 again here, and the numerator here will be 5. Let's do the same with the second one. Here the lowest common multiple would be 5x, and we would have 10 here, because what we've done is we've multiplied the top and bottom here by 5. We're going to multiply top and bottom here by x to get 4x over 5x. And this is the same one that we had before, so we had 2x, x plus 2, over x plus 1 times x plus 2, plus 5 times x plus 1, over x plus 1 times x plus 2. Okay, so now that we've written these calculations here with common denominators, we can actually add or subtract them. So now we combine the numerators with the subtraction here, with the add here and the add here. So now what we do is we say, okay, 12 take away 5 is 7, and it's still over 20. And here we've got 5x as our denominator, and the numerator would be 10 plus 4x. And this one here, I'm just going to work down here, 2x squared plus 4x plus 5x plus 5 all over x plus 1 times x plus 2. Okay, so now that we've written it as one fraction, these are fine as they are, and this one can still be simplified here. So we're going to do that and finish it off. So we've got 2x squared plus 9x plus 5 over x plus 1 times x plus 2. So notice how simplifying these are similar. I'm just going to go through a few more examples to show where some people sometimes often go wrong. So here's another one, looks quite similar to one of the ones that we had before, but this time we've got a subtraction. Now, the common denominator here that I'm going to use is 2x take away 5 times x plus 1. So multiply the first fraction, top and bottom, by x plus 1. So we're going to have 3x times x plus 1. And in the denominator I'm going to have 2x take away 5 times x plus 1. And the second fraction is going to be multiplied by 2x take away 5 to the numerator and denominator. So we're going to have 2 times 2x take away 5 over 2x take away 5 times x plus 1. Okay. Now we're going to multiply it out, but I'm not going to put the fractions together now. I'm only going to multiply this out, and I'm going to multiply that out. So what I'm going to have now is 3x squared plus 3x, and here we've got 2x plus 5, x plus 1, and on this I'm taking away 4x, and here we're going to have, so here what I'm doing is 2 times negative 5. That's going to give us negative 10, and 2x take away 5 here, and x plus 1 here. Now when I combine these fractions, the denominator is the same, and I've got this numerator and I need to subtract this numerator. Now subtracting all of this numerator is where often people go wrong, and I'll show you what that looks like. So we've got 3x squared plus 3x. What I would recommend is that you write take away all of 4x take away 10 in a bracket. What that does is it tells you that you need to take away the 4x and you need to take away the negative 10, which is actually adding 10. So let's finish this one off. It's going to be 2x plus 5 and x plus 1. And then in the end what we're going to have is 3x squared plus 3x, take away 4x, add 10. Okay, so notice how this taking away this negative 10 is like adding 10. Okay, sometimes I think people often like to write the 1 here to show that it's a negative 1 times negative 10 that they're doing, which gives them this add 10 there. And then the denominator is going to be 2x plus 5 and x plus 1. Okay, and then we can see that we can simplify these two here, so we're just going to do that, and that then becomes 3x squared, take away x, add 10 over 2x plus 5 and x plus 1. Here's an example where you can make extra work for yourself if you don't spot something. So here what we've got is, in the denominator here I've got x plus 1, and the denominator here I've got x squared plus x. Now this factorizes. Let's see what happens when this factorizes. So I'm just going to rewrite the whole thing. So we've got x over x plus 1, take away. So now I'm going to factorize this denominator. We're going to have 3 over x times x plus 1. Now notice how I've got x plus 1 here, and I've also got x plus 1 here as a factor. So x times x plus 1. So our lowest common multiple is actually x times x plus 1. So this denominator can stay the same. But if I multiply top and bottom here by x, what I get is I'll get the common denominator that I need. So what I'm going to have is x squared over x times x plus 1, and take away 3 over x times x plus 1. And now what I have is I have my common denominator without needing to multiply anything to this fraction. Okay, so last thing now, we just need to do x squared take away 3 over x times x plus 1, and that's it. I'd like you to answer these questions and bring the answers to the next lesson, please.